Greetings, Trip Zero here, and I'm going to explain a little bit about the Geohouse pumping system and irrigation system. First, what we have here is a component box. It's got a pump in it, two solenoid valves, electronically controlled, and we've got a flow sensor right here and a little sediment filter on the intake. So the water from the reservoir, which you can see on a previous video, comes into here. It's already been filtered as it exits the rain barrel system, but this is just to catch whatever the filter didn't, or maybe there's something in the reservoir we don't want to get in the pump. Extra precaution. Then we have, as it enters the component box, we have the pump. Exits the pump here, goes into this T-joint, and out here. Now, why a T-joint? Well, both of these aren't going to be on at the same time. This one on the bottom, this one right here, well, I guess the top of the screen, is a normally open. So during typical operation, it'll be pumping through here, and this is going to be for the heating and cooling system. So it'll be coming from the reservoir, which gets fed from the rain barrel system and the ground in here, and then into the soil bed through the PEX tubing, then down into the ground and back up. Okay, and these are tied together, so when you close this electronically, this one, which is normally closed, will open up, and the water will flow up here, and this will go to the irrigation system. So it'll water the plants. And the reason why I'm doing that is because, one, I think it's not going to be healthy for the plants to be watered with extremely cold water. Two, to get the necessary pressure, you want a pump, and so I already have a pump. Why not use the same pump for both? So right here I can maintain the same temperature as the water I'm using to water the plants as the stuff that I'm getting from the ground, the stuff that's being thermally produced anyway. Yeah. So that's that. One more thing. So how am I going to control the temperature? Well, I'll have another box similar to this. It's going to have a photon controller, a little microcontroller that's Wi-Fi enabled, using the PID algorithm, which is just a climbing the hill type algorithm, where you can set a set point and then specify an input, and it tries to give you some numbers to use with the pump that will hopefully reach the set point. So what I've got it set as, the set point is 0, and I'm taking the air temperature and the soil temperature delta, and I'm using that to try and reach the set point of 0. So for example, if it's 70 degrees and my set point is 60, the delta of that is 10. And so this will try and go from 10, actually negative 10, because I make it always negative 10 up to 0. So it'll climb the hill until it reaches 0, till that delta is 0, which means it's going to be 60 degrees in the soil. Well, actually, that's not, in that example, that's not necessarily true. It'll just keep on going, which I think is good. If the air temperature is 70 and the soil temperature is 60, what I want it to happen is the soil temperature, I want to keep it cool, so that's why I'm activating the pump. And that will help cool the air, but it'll also take the excess energy from the air. The air, heat energy from the air is going to be transferring into the soil. I'm going to be transferring that from the soil into the ground, into my ground battery, so I can use that later during the nighttime. So whether it's too hot and I'm trying to cool, or whether it's too cool. For example, maybe the ambient air temperature is 50 degrees, and I want to be taking the energy from the ground in that case and putting it back into the soil. And hopefully some of that will radiate into the air. So I think that explains it. So there's a little bit of algorithm involved in regulating the pump. The output is voltage, so this is a 12-volt pump. I'll be going down to whatever voltage it stops working at, to depending on down to 0 optimally. If the temperature is 60 degrees, then this will stop working or turn off, saving energy. So that's the pumping system. And I'll see you next time. Trip Zero out.